Welcome, Calculus. This is section 5.2, the natural log integration. The essential question is, what is the rule for integration of natural logs? Let's begin. So if you try to integrate this integral right here using your power rule, what happens? Well, you convert this to integral of x to the negative 1 power dx, and then following the power rules, you say, well, it's add 1, so x to the 0 divided by 0. Wait, you can't do that. And that's right, because there's a special rule for integrals of 1 over x. And that comes out to be the log rule of integration, so make sure you write this down. So the integral of 1 over x dx is the natural log of the absolute value of x plus c. Why do we do the absolute value? Can't log a negative. A negative. So like natural log of like negative 1, can't do that. That's undefined. So we make sure that it's going to be a positive number in there. Alright, so let's have some examples. Here's the integral of 2 over x dx. Well, I can break this up to 2 times the integral of 1 over x dx, which is going to be 2 times the natural log of the absolute value of x plus c. This one down here, 1 over 4x minus 1, we're actually going to have to use u substitution. So u is 4x minus 1. du is going to be 4 dx. So I need a 4 right here. I'm going to put a 4 and then also divide by 4 on the outside. So when I substitute in u, I get 1/4 integral of 1 over u du, which is going to be 1/4 times the natural log of the absolute value of u plus c. And if I substitute back in, I will get 1/4 the natural log of 4x minus 1 plus c. And there's my answer. All right, let's try another one. So this one right here, so integration here, this is also going to be a u substitution. I'm going to do my u is going to be the bigger expression on the bottom, x squared plus 1. du is 2x dx. I don't have a 2x, I put a 2 here, must also multiply by the reciprocal outside. So the integral is 1/2. The integral of 1 over u du, which is going to be 1/2 natural log of the absolute value of u plus c, which is going to equal 1/2 times the natural log of x squared plus 1 plus c. In this case, I don't need the absolute value because x squared plus 1 will always be a positive number. Anything squared is going to be 0 or above. So I can say 1/2 natural log of x squared plus 1 plus c if I wanted to. All right, try another one. So you look at this and you go, wait a minute, so maybe I try u substitution. I try x squared plus 1 and du is 2x dx, but that doesn't match the top. This doesn't work out. So this is one of those cases when you have the same power on the top and bottom, or if the top has a greater power, they're both 2. What you have to do is you have to do polynomial division. And here's how it works. The divisor is going to be x squared plus 1. The dividend is x squared plus x plus 1. So I like doing long division. If you want to do synthetic division, that's fine. So x squared, you always look at the first term, times what is x squared? Well, it's x squared times 1. 1 times x squared is x squared. 1 times 1 is 1. Subtract these, and this goes away. This x drops down, and then this becomes 0. So all I have as a remainder is x. So my polynomial is now 1 plus x over x squared plus 1. I'm going to rewrite this as 1 plus x over x squared plus 1 dx. Integrating this, integral of 1 is just x. This thing, we're going to have to use substitution. So just for this part here, my u is going to be x squared plus 1. du is 2x dx. So I want to put a 2 here. I'll have to compensate and put a 1/2 on the outside. So this is the integral of x. It's going to be 1/2 the integral of 1 over u du, which is going to be x plus 1/2 natural log of the absolute value of u plus c. And plugging in that for u, you get x plus 1/2 natural log of x squared plus 1 plus c as your best answer. All right, next thing. So as a note, you can do integrals of the basic trig functions. These first two you've probably done before and you know this. These other ones are weird, but these are different. They involve natural logs. I'm not going to ask you to memorize this. Just note that this does exist, and if it comes up, you're going to have to reference it later. All right, let's do some examples. So, pause the video. All right, you're going to find the indefinite integral. So integrating this one, it's the same thing as saying 10 integral of 1 over x dx, which is going to be 10 times the natural log of x plus c. This one, use substitution. Your u is going to be 5 minus 4x. du is going to be negative 4x dx. So you plug in. I don't have a negative 4 up here, so I have to have a negative 4. I'm also multiply negative 1/4 out here and take this 9 out, so it becomes negative 9/4. The integral of 1 over u du. Integrating that, that's going to be negative 9/4 natural log of u plus c, which is going to be negative 9/4 natural log of 5 minus 4x plus c as your answer. Last one. Pause the video. Okay, we're going to work on this. So this one's a little tricky. It's u substitution, but your u in this case is actually log of x, and your du is going to be 1 over x dx. This is 1 over x dx, kind of like with these groups. So it's going to be the integral of 1 over u du, which is natural log of u, which is going to be natural log of x, going from e to e squared. That's going to be natural log of e squared minus natural log of e. Now natural log of e is going to be 1, so this is log of 1, and of e squared, that's going to be natural log of, this is going to be actually 2 here. And natural log of 1 is 0, so it's ln of 2 minus 0, or which is just ln of 2. Thank you, my class has to go, we're done.